welcome to another F12 programming. My name is Mike Hewitt.
I'm Jacob Rains.
And today I think we're talking about string builders.
String builders and strings in general.
I do love string builders.
So we've got our little program here we've been working with for a while. We're going to use just for example here. So the problem with strings, I say the problem, they are an immutable, which means that they cannot be changed.
Yep.
It feels like they can be changed. They feel like value types, but they're reference types, because we do things all the time where we say string x equals x, string y equals y, and then we'll say things like string z equals x plus y. That very much feels like a value type, like something we would do with an integer. We don't usually add objects together.
Or a lot of times people say X will be my name is, and then they would go later on and say add their name and then finish up the sentence.
Right? Or
explain
even
kind of what's happening behind the scenes.
So strings are, they actually are technically reference types, and they are stored on the heap, which they take a little bit of a performance hit for. But anytime we add two strings together, because they are immutable and they cannot be changed, we actually ditch those two strings and make a new one. So if I had said x equals x plus y here in this scenario, everybody imagines that when we're done here, x is going to be equal to these two strings concatenated together. But they might imagine that there's only two strings involved here, x and y, and then we replaced x with the new string, which was the concatenation of the two. That is not what happened. X and y get thrown to the wind, more or less, and a new third string gets created with the new value. This becomes problematic when we start putting together lots of strings.
Right.
So when we've got, or even worse, if we're doing it in a loop, like if we've got a loop and we're iterating through 1,000 values. So if we make a loop here real fast, and we go from
have the string go 1, 2, 3, 4. Just keep adding numbers to it. Yeah,
that's exactly what I was thinking.
Go.
So string a equals, we're going to just set it equal to a blank, and then we're going to say a equals a plus i.toString. And when we're done, let's go ahead and just console write line a. So we're going to loop this 100 times, and we're just going to add it on here. And I have an error. Because I
variable,
declared it twice. So we end up with this code, and you can see it added it all together into one big long string. But
so,
how many strings did we just make?
You would
No. Let's see if you get this one right. This was a tough one. How many strings did we just make?
We made 101.
We made
100.
200 plus, because how many did we make? Yeah, so at every single pass through here, we took i.toString, which made us a string.
Yeah.
With a 1 through 99 in it, or 0 through 99 in it.
Oh, okay, yeah, right.
And then we added it to A, which made a new string. So we've actually made like 200 strings here, and in the end, we only have one as our output.
So where do those strings go? Because obviously, if you looked up at A, and finished A.
Each string got longer than the one before.
Yep.
So looping 1 through 100 isn't too bad, but if we were to loop through 1,000 or 1,000,000 or some larger numbers, we keep creating ever larger strings that we just immediately discard, and those strings eat up memory space until the garbage collector comes through and cleans them out, which becomes a complex problem, because now we have this huge amount of memory that's taken up by strings, and we have this overhead on the string build on the garbage collector, and there's a bad way of doing it. There's so many better ways to do this. The best one is the string builder. So instead of A, let's just make string builder. I'm just going to call it SB. And instead of this, we're going to say append SB. And actually, I believe, will it take an int? It might even have an overload that takes an int. I can't remember.
I'm almost 100% sure. Yep.
Yeah, I thought it did. And then we're done. We're going to put SB here, which, just for clarification, I'm going to put toString here. So
once you're done and you got it where you want it to, then you turn it into a string.
Yeah, so until you hit this toString, you didn't make any strings, right? So what it does is every time, what it actually does, and I want to say the number is 1024, don't quote me. It goes ahead and reserves 1024 characters worth of memory space, and knows that none of them are in use. And since that memory's already been pre-allocated, until you hit 1024, this is a very lightweight thing to do. When it hits 1024, it doubles. So it goes ahead and makes a new memory space for 2048. And if it hits that, it'll make another one for 4096, 8194, etc., etc., etc. So it doubles every time. So if you put, and I'm just making up numbers here, but if we put 5,000 characters into this string builder, the downside is we're eating up 8,000 characters worth of memory. That's a small price to pay for not having to concatenate strings together.
Right.
When this runs now, we are going to see that it... Well, it helps if I close that one out. Hang on. There it is. We're going to get the same results, and you can't really feel it, but that was a lot faster.
Yes.
It's microseconds at the simplicity we're at here, but it adds up over the course of your program, and more importantly...
And it snowballs.
Yeah, more importantly than the speed. Yeah, you can... I have seen strings bring a program to its knees. If you start working with strings that are a megabyte of data, which isn't that much in the grand scale, XML documents can be 50 megs.
Right.
If you start manipulating a 50 meg XML document as a string, you will bring the system down.
Yeah.
It's just not a good way to work. String builders wrap all that up and handle it for you. They're a quick way of doing it. One last thing I want to throw in there, for those of you who haven't used it, is .NET's built-in string interpolation now that they use. So we can say string A equals... I'm going to go ahead and put a $sign in front of the string. If you haven't seen that before, it is a neat thing you can do. So now we can say...
Can you show the old way first?
Yeah, let me show the old way first. The old way, the correct old way, or the bad old way?
Either way.
The bad old way is string A old equals X plus space plus Y. That's not just old, that's bad. Let's clarify, that's bad.
Right.
String A. The old way of doing it is to say string.format,
which I have everywhere in my code.
Yeah. And we would say variable 0 and variable 1, and then we would specify that variable 0 are X and Y. This is a fast, lightweight, great, easy way to do it. It's just a lot to type, and it's not clear looking at
because you kind of have to go to the end and then continue back in.
Yeah, so the 0 is this, and the 1 is this.
But
and
if
then,
you have text in the middle...
And then if somebody does this, it breaks.
Right.
So you can do this. That's okay. You can put another variable here at the end. That's okay. But if you put a squiggly 2 in here and there's not another variable, it breaks.
Yeah.
So this is a much easier, friendly...
And it's actually readable.
And it's readable. Again, this directly translates to this when you compile, so there's no performance lag or no reason not to use it this way.
Yep. So. Yeah. Brilliant. And that last one saved me a lot. So.
Thank you for watching that video from F12 Programming. Please remember to like and subscribe. That does so much for us in the ratings. You have no idea. Also, don't forget to comment below. I hope you enjoyed, and good luck coding.